All right, so apologies again for not being able to be here directly live, but as you're playing this, I am going to try to be, if you're at the normal time, I'm going to try to be chiming in with chats if you want to chat with me side by side here. So hopefully those will work. Worst case, you can always watch this again and again, slow it down, pause it, go back. Um, Today, or what we have left for this week, pretty much, is just the stuff out of chapter 7.3. So I'm going to begin with that immediately, and then we'll do like always, do some homework problems, and then I'll send another video to talk a little bit about the quiz here, but we'll just do section 7.3 along with the homework today. So let's just get this full screen here so you can see it a little bit better. So we've done a lot with the trig stuff already, and we've been solving, we've been finding values, evaluating lots of different pieces. Today we're going to actually solve equations. Now, and the good part about this is as long as you are applying what you remember from algebra and then applying what you've learned for what sine and cosine are, remember that same table? Let me get that out here. This table right here. It's a combination of knowing these along with knowing how to just solve basic equations. And from there, we're going to be okay. There's going to be a couple wrinkles here and there, but for the most part, it's just combining two concepts. Okay, so in the first case, you have to think about when you first learn how to solve equations, you were being asked things like, is x equals 5 a solution of some equation they give you? And the idea is you plug it in and you see if it's true. So here in the beginning, we're going to do the same thing. We have the equation 2 sine theta minus square root of 3 equals 0. They're asking, is pi over 6 a solution to this? So this is another part here, but just the pi over 6, the idea is plug in the pi over 6 and replace all thetas with it. Just like how in regular old equations, you would replace all the x's with the potential number. Here we're going to replace all thetas with the pi over 6, and we're going to check to see if it's true. So you plug in pi over 6, you get 2 sine of pi over 6 minus root 3. And again, it still equals 0, but I just want to see if this side equals 0. So remember what the sine of pi over 6 is. That's our 1/2. So when you take 2 times 1/2, you get a 1. 1 minus square root of 3. And that is clearly not going to be a 0. So what that tells you is pi over 6 is not a solution to this equation. All right, and that's how it's always going to work is you can plug in anything you want. One or two or three are going to work. Sometimes none of them work. A lot of times other ones don't work. It's a matter of just testing it. And why they're showing this is something we're going to be doing as you solve these equations. We're going to use techniques just like the ones you had in algebra, but there will be times where even following the technique, you're a little unsure. And remember, you always have the ability to plug it back in. If you ever have any doubt, should I have divided by 2? Should I have multiplied by 2? Do them both and plug them both in, and it'll confirm to you which one was the right way. So now the same equation they want to ask is theta equals pi over 3. Is that going to be a solution? So just like before, replace the theta with the pi over 3. Sine of pi over 3, recall, is square root of 3 over 2. So we get 2 times root 3 over 2 minus root 3. The 2's cancel off. We get a root 3 minus 3. And lo and behold, we do get a 0. Thus confirming that pi over 3 is a solution to that equation, 2 sine theta minus root 3 equals 0. Okay, so you're going to get those first couple problems just like that. It's fairly straightforward. Literally, when they ask you, is this a solution? You replace every theta with that potential value, that potential solution to see if it is in fact giving you a true statement. Okay, so now they give you an equation, cosine theta equals root 2 over 2, and they want a general formula for all the solutions. Now, list 8 of the solutions for which it's true. Now, when you look at this, if you recall, just from our table, and I'm going to go back and forth, pull up our table here. Remember, where is cosine equal to root 2 over 2? Well, it's right here at 45 degrees, or pi over 4. It's also down here at 315 degrees, or 7 pi over 4. So what they're asking for is, number one, they want 8 solutions. Well, here's 2 of them, And you know how we can do this. You can just simply keep adding 2 pi to each of these solutions. So if I have pi over 4, I can add 2 pi to that, and that's also a solution. I can add another 2 pi to that, another 2 pi. You can keep going on forever. But the main idea is start with the 2 that you know. Remember this pi over 4, this 7 pi over 4? And then from here, now we'll get to this general solution stuff, but let me just show you. When you have this pi over 4 right here, you can add 2 pi to that, and that's how you get the 9 pi over 4 and the 17 pi over 4. Just like if I was to take the 7 pi over 4, I can add 2 pi to that to get this and this. So all of these, and these are subtracting 2 pi, these are all the matching solutions. They're all the same. So all the ones I circled in black, they're going to be all stemming from pi over 4. All the ones in green are all equivalent to 7 pi over 4. So these are 8 solutions, and you can go on and on. You just keep adding 2 pi again and again, and you're going to get these answers. But the question now is, we want to come up with a general solution. So go back and you look at these two. Just this is the first solution right here. This is the other one. Okay, so what you're going to do is you're going to make 2 equations. From the first one, you simply say, well, I'm going to add 2k pi. And this is going to be pretty much the answer all the time. In both cases, we're going to add 2 pi k. And what that means is if k is any integer, if k is 0, then that's pi over 4 plus 0, that's the pi over 4. If k is 1, then we're adding 2 pi to this, and it's that solution. If k is 2, we get that solution. Same thing with these over here. If you put a 0 for k, you get that one. If you put a 1 for k, you get that one. And you see how this covers all of my solutions. And this is what they mean when they say a general form. Okay, and sometimes this is going to be the hardest part of the problem. It's just trying to come up with, without listing all the answers, can we sort of create a little pattern, a formula, a little program to show all the answers that we might get? Okay, so pretty much that's it for that one right there. We have all the different solutions. So now we want to look, and now we have another example, sorry. Here's the 8 solutions. And remember, you can add 2 pi, you could subtract 2 pi, just go as far as you want. There is no requirement it has to be these 8. It's just any 8 solutions. Okay, for this one, we have the equation 2 sine theta plus root 2 equals 0. So I'm going to write again kind of off to the side here just to give you a little bit of a, show you some of the work here. So let's do this. Okay, so as I'm doing this one, just remember, think algebra. Okay, so I have a 2 sine theta plus root 2 equals 0. Okay, so let's get rid of this just so you don't look at all the rest of the problem here. Now, if this was an x instead of a trig function, think of how you would solve it. Well, I would move this over, I would divide by 2, and somehow in the end I'd get my answer. It's pretty much the same thing over here. I can't get the theta by itself immediately, but I can get the trig function by itself, whether it's a sine, a cosine, a tangent, or whatever. You can get that by itself. So we subtract the square root of 2. We divide both sides by 2, and you notice, hopefully, there's something interesting here. Look at what sine is equal to. This is one of our familiar values. Once again, let me show you our table that you hopefully are starting to memorize. But look at all the places that sine of theta equals root 2 over 2. It's here at 225 degrees. It's here at 315 degrees. So from our table, I know that my solutions are 5 pi over 4 and also 7 pi over 4. Okay, so those are my first 2 solutions. And the final way to come up with what they call that general solution is you take the first answer and you simply say 2k plus 2k pi, and that'll cover everybody. Then you take the second answer and you say also 7 pi over 4 plus 2k pi. And these are my general solutions that tell me every possible answer out there. Okay, so that's the process here when you're doing that. You see how, like I said, you're doing some algebra, then you got to remember your table, and then you have to make it generalize. And the nice part is when you make it generalize, there's it's always the same thing. Now, I didn't read the problem. On this one, they didn't say give the general solution. They said give me only thetas between 0 and 2 pi. So if that's the case, you give me that and we're done. That's all you have to do. Okay, now it depends on, like I said, what they're asking. If they wanted the general solution, then yes, we bring that back. If they want specifics and they specify the range, that's easy for us because now we pretty much have our answers. So do what I didn't do. Make sure you read the instructions here on each of these so you know where to go on these. Okay, so on to the next one. We have sine of 2 theta equals root 3 over 2, and they want all the answers between 0 and 2 pi. Now, this one's a little bit more unique here, so I'm going to write this up on the top and just kind of show you the process, what I would do if I was doing this one here. Okay, so we have sine of 2 theta equals root 3 over 2, I think. Yeah, root 3 over 2. And this is the very important other piece to this equation is they want only answers between 0 and 2 pi. Nothing bigger than 2 pi, or you can't even include 2 pi, and no negatives. Okay, so that could help us, but let's see what we're doing here. Now remember, this is what we have. We want to get the trig function by itself, which we have. Now we go on our table, and like I told you the other day, I'm hoping that as you do more and more of these problems, you'll start looking at this table less and less. Okay, but it looks like from square root of 3 over 2, I've got an answer for sine of this one. Where is it? Right here. 60 degrees and 120 degrees. So my solutions are pi over 3 or 2 pi over 3. Okay, with me so far. So now the other unique kicker is because this was a 2 theta, not just a theta, this is what equals both of those. Okay? It's 2 theta equals pi over 3. It's 2 theta equals 2 pi over 3. So the right sides are what we normally have been doing on the last couple of problems. But now they're equal to 2 theta. Whatever is in this parenthesis, that's what you are solving. That's what you set equal to the values you obtain here out of this table. Okay? So now if you look at it, how do you get theta by itself? Well, you know how to do that. You divide both sides by 2, and you get pi over 6. Over here, divide by 2, and we get 2 pi over 6, which reduces down to just pi over 3. Okay, now, here's the one part that's a little bit of a kicker for you all. We have this. We have our solutions. For the most part, when you solve a normal trig function, you're going to get 2 solutions. However, when there's a 2 theta inside, or you have a square theta for whatever reason, that's going to double your answer. So we should have 4. Well, kind of hard to see because I look at my table, I don't have any more, but this is the caveat. When you have a problem that has a 2 theta or a 3 theta or whatever, you have to go a step further. So you see this one right here. I'm going to bring this back down again. Let me not box that, but let me just say, I'm going to take this equation right here. And what happens is, remember, 2 theta equals pi over 3, but it also equals pi over 3 plus 2 pi. You can add 2 pi to that. Now, here's the interesting part. You don't add 2 pi to this because that's going to take you out of our range here. But you add it to the original that you found. Just like this one right here, I'm going to make a second equation that says 2 theta equals 2 pi over 3 plus 2 pi. So now you solve these, and let's say I divide everybody by 2, I get theta equals pi over 6 plus pi. Here I get theta equals 7 pi over 6. Over here, again, I divide everybody by 2, or you can get a common denominator if that makes you feel better. Some of you like that, some of you don't. 8 pi over 3, divide both sides by 2, and we get theta equals 4 pi over 3. All right, 8 pi over 6 becomes 4 pi over 3. Now, what's the interesting part is these two solutions from the beginning were normal, but when we made a second equation, you see how these two solutions also work? They are within the specified range that we were told. So this is the case, like I told you. Normally you'll get two answers. If you have a 2 theta, I want you to click on your brain and say, wait a minute, there's something more. There's an extra step. 2 theta means double the answers. So I need to create a third and a fourth equation. And when I solve those, I promise you guys, when you solve them, you're going to get two more solutions that are between 0 and 2 pi. Okay, if this happened to be 3 theta, you would add another 2 pi and another 2 pi, and you'd solve again. Okay, if that was a 3 theta to start, because you would have tripled the answer. So you got to keep going. And if you're not sure, keep adding the 2 pi. At some point, this solution here that you get may be too big compared to 2 pi. That's how you know you stop. That's how you know you reach the end. Okay, so again, an interesting problem. It has some extra steps, but that's what you're going to do when you solve these. So let me just run through this one real quick, and hopefully they get the same answers we got. And you see what's going on here. Because this was a 2 theta, it's a compressed graph, which means instead of our normal 2 times of intersecting, there's going to be a couple more because we squeezed everything in. Normally, it would have been just one and done, an up and a down, a normal sine function. But because of the 2 theta, it's squeezed in here, so we have a double. And we have these extra 2 solutions. So they use the general solution, which would have worked, and they start plugging in different k's. But in the end, I believe we got a lot going on here. Oh, yeah. So they kept going. They took both general equations, and you see which ones are going to work. No negatives, because we want it between 0 and 2 pi. Let's make sure. Yeah. So they wanted this. That was the original problem, between 0 and 2 pi. The process here is they just went with the general solutions just to kind of show everything. These up here, oops, sorry. These right here, negatives. You can't have a negative. That one right there, no negatives. That, no negatives. Here, this is bigger than 2 pi. This is bigger than 2 pi, but these work, and these work, and these are the 4 solutions I have. Okay, so that's what they would be doing when you're doing the general solutions. Either way is going to give you the same answer. Okay, so your solution set is just these 4 right here. And what this last part is showing is when you plug in, where is it? Sorry, pi over 6 into the original equation, you plug in pi over 6 right here, you get root 3 over 2. When you plug in pi over 3, you get root 3 over 2. When you plug in 7 pi over 6, you get root 3 over 2. You see the pattern? That's what we're supposed to get. We're looking for anything that gives you a root 3 over 2. Those are our 4 theta values that make it true. Okay, so now we're going to solve a trig equation with tangent. Now you see it's got this extra little shift there. All that means is you have to include all of that in your answers, and there may be some compensating you have to do, like I did on the last problem. So I'll show you this one here. So first off, they mentioned the period of tangent is pi. All right, if you recall, we've done this where tangent repeats every pi. So you normally might have to do this twice just to get answers between 0 and 2 pi. Now, that's not the most important thing. What is important is when you start plugging things in. If you start thinking about all this, let's go right here. Let's just get the answer. All right, so we got to think, where is it that we get the solution? Okay, so going back, they didn't, I want to make sure I'm not skipping anything that they want to do right here. Okay. Let me show you on the side here. So recall the original solution, the original equation is this one right here. They want to know if tangent of theta minus pi over 3 equals square root of 3, what are my solutions? Now again, all your answers need to be here. Okay, so now all I'm going to do is I've got the tangent by itself. Let's focus on the root 3. So if you recall from a number of examples we did the other day, tangent is sine over cosine. How do you get a root 3? It's when you have the sine being a root 3 over 2 and the cosine is at 1/2 and the 2's cancel and you're left with a root 3. Okay, so I'm looking for the places that'll be true. It's going to be here, and then of course it's going to be right here, because again, when you take negative root 3 over 2 divided by 1/2, negative 1/2, the negatives cancel, and again, you're left with a root 3. So my two solutions are pi over 3 and also 4 pi over 3. And just like the last example, whatever's in there, all of that is what equals the solution you came up with. So take this out of here, and now we're going to look at how to solve for theta. So I'm going to move this pi over 3 to the other side, and we get 2 pi over 3. I'm going to move this pi over 3 to the other side, and we get 5 pi over 3. So right now we have two solutions. The only question we got to worry about is, are there other solutions? Could there be more? Okay, sorry. So how do we do that? A couple ways I can show you here. Let's go with this color right here. See this? Always go back to the first equation right after you start ready to, after you've removed the trig function. So remember, I can also say this is going to be the same as if I add 2 pi to it. You can take any original solution, this pi over 3, add 2 pi to it, and then let's see what we get. We get a 2 pi over 3 plus 2 pi, and right now I already know too big. It's greater than this 2 pi, so that's gone. This one over here, it's going to be the same thing. This equals 4 pi over 3. When I add a 2 pi to that, we're going to be too big. So looks like we have our only two solutions. The last thing, though, you want to make sure of, let's just look over here. Let's take the bigger one now. Let's take that one, and remember, you can also subtract 2 pi. See what that ends up with. So we just simplify this like a normal equation. Just think again, algebra. So I got a 4 pi over 3. I'm adding a pi over 3. I'm adding a 2 pi. I can see right now, yep, that's too much. That's going to be, subtracting 2 pi. Go back. I forgot. We were subtracting that one. Let me get my part cleared there. Okay, now let's actually go work it out. This gives me 5 pi over 3 minus 2 pi. This gives me 5 pi over 3 minus 6 pi over 3. It wasn't by much, but yeah, it's a negative answer. That's why we throw it out, because again, you can't go smaller than 0. So you want to play around with both versions. Let's just add 2 pi to both answers, subtract 2 pi from both answers, and then in all the cases, solve for the theta. That's then when you check, is my final theta between 0 and 2 pi? Okay, keep going until you get out of bounds. That's when you know how to stop. But remember, it's this equation right here, the one right after you got rid of the trig function, that's the one that you add 2 pi to. This one right here, right after you remove the trig function, that's the one you add 2 pi, and then also subtract 2 pi to see what you get. Okay, so that example done. Now we can kind of look and see this is the same thing I believe they got right here. Similar approach, they went with the general formulas, and that's what I was doing. Remember, I was adding a couple of pi's, 2 pi's, and all that. But in a trig function, you can add a regular pi, and it'll work as well. But we've gotten all of our solutions there, so we're good. All right, now they have the calculator problem. We have the tangent of theta equals -2. And once again, we want our answers greater than or equal to 0, but less than 2 pi. All right, so in the calculator, you kind of can read this, but I'll show you how to punch this up. Remember, this is another different process, but we're going to use the rewrite of this and say theta equals inverse tangent of -2. We're just doing the rewrite of this. Okay, so when I plug this into my calculator, plug in the -2. We do want to be in radians, so make sure we're in radians. And we hit the second or shift, and we hit inverse tangent, and you see you get a -1.1071. Yeah, to nearest 2 decimal places. So let's make that -1.11. Okay? So this is my theta, but remember, you got to be here in between. You have to be a little bit, you're out of bounds right now. You have to be greater than 0 and less than 2 pi. So clearly I have a negative number, so I have to fix that and remember what the solution is, okay? Making sure they did this right. Yep, they did it. We're going to take this, because this is out of bounds, I'm going to add 2 pi to that. And you can do that right here on your calculator. You just leave that on the screen. Let's add 2 times pi. And we get this 5.17. All right, make sure that's, yeah. Okay, so we do that. And remember, this is the equivalent, 5.18 we'll call it. You can add 2 pi to something, and all it does is spin it around one time, but it's the exact same solution. Exact same one there. Okay, and that's where we get this one. Now, if you look at this, there's another piece to this, and I'll show you this. Let me show you this with a graph a little bit. Okay, so think about tangents for the tangent function. All right, we're going with radians. So this is pi, this is 2 pi or 0. This is pi over 2, and this is 3 pi over 2. So when I say tangent of theta equals -2, where is tangent negative? Well, it's positive here, negative here, and it's also negative over here. So there are actually 2 places where you're going to get this happening. There's going to be somewhere over here that has a tangent equal to -2, and then there's going to be somewhere over here, same thing, that has that. Now you notice in our calculator, we only got one answer. We got this -1.11. The reason is, remember the restricted regions. When you do an inverse tangent right here, you can only get answers from the first or the fourth quadrant. So when I do an inverse tangent in my calculator, it knows the rules, and it's saying, okay, only give a tangent that's in the first or fourth quadrant. And that's what it gave me. It gave me this -1.11 in the fourth quadrant. I rewrote it. It's still in the fourth quadrant. So this right here, this is the 5.18. Now the issue is, we want to get this one. We're never going to get that on the calculator because that's in the second quadrant, and we don't have that. That's not going to be able to, it's never going to show. Good news is, tangents are essentially parallel to each other, or they're back to back to each other. So once we get this one, this 5.18, we did that by adding 2 pi. You could have done the same thing and take this -1.11, and you could have added a single pi to it. So just going back to my original equation, it was this one. That's -1.107. I added up 2 pi. I could have just added a single pi, and I also get a second solution of 2.03. All right, so this only works on tangents. If you get a solution for tangent on your calculator, just remember, you're going to have to get two answers. So add pi, add pi, add pi, subtract pi, subtract pi. Eventually, you're going to get two of them that are in between the range of 0 and 2 pi. That's what we have right here. Let me erase this, and you can just see. There's our two solutions. And if you forgot, you're looking for decimals. Remember, greater than 0, less than 2 pi. Now, none of these have pi's in them because they're all decimals. Just remember, this is what 2 pi is. It's at 6.28. So any solutions that are positive and less than 6.28, those are the ones you want. So keep toggling around, and then eventually you're going to get 1 or 2 or 3. It just depends on what the example is, what the problem is. Okay, so another one. This sort of is the illustration that I was trying to draw here, remember? Negative 1.11 is right here. This is my theta. Well, you can add 2 pi to that to get our, wherever it is, right here in blue. They didn't write the answer, but remember that was that 5.17. And then also, you could have just added a single pi, and that'll bring you right back to back. And that's the nice thing about tangents is all the answers are back to back. They're always pi units apart. And that's because the graph of tangent is, it's a cycle of a pi. It's a period of pi. Remember, we did that a couple days ago. Okay, so let's look at number 20 here. We're going to solve this equation. Now, it gets a little more algebraic, but again, if you follow your rules from before, you should be okay. We want to get 4 sine square theta minus 1 equals 0. So when I do this one, let me show you. We don't want to forget. When you normally solve a trig function, you're going to get two answers, usually two answers. If you have a 2 theta, you're doubling your answers. If you have a 3 theta, you're tripling your answers. Same thing when you have a square or a third right there. You're going to double your answers. Okay, so this square function means we should probably have 4 solutions. So I'm just going to kind of put a little note here. 4 possible solutions. Will we get it? Maybe, probably, but it may not be the case. And we also have to be between 0 and 2 pi. Same old rules. Just got to make sure we follow where we're going here. So when you solve this, here's what I'm going to tell you. This is similar to solving the equation 4y squared minus 1 equals 0. Think about how you would have solved this one, and it's the exact same way you would solve this one. Now, what I'm hoping is you do remember, when you get a square power, you're supposed to put everything on one side, set it equal to 0, and then factor. So we have everything on one side equal to 0. Now I'm going to factor, and watch how I factor this right here. Remember, a square and 1 is a square, and there's a difference. There's a subtraction in the middle. This is going to be the difference of 2 squares. I have 2 sine and 2 sine. You guys see when I FOIL that, that gives me the 4 sine square. Then I have the plus 1 and the minus 1. That's how I get the minus 1. And you don't have to write this next step, but just think about it. If I was to FOIL this out, I would get 4 sine square. I would get negative 2 sine theta. I would get positive 2 sine theta. And I would get negative 1. These cancel, and I'm right back to where I started, that 4 sine squared minus 1. All that was just a little confirmation to show you all that, yes, we factored this correctly. Okay, so we have 2 sine theta plus 1, and we have 2 sine theta minus 1, and they're equal to 0. So go back again and think of your algebra. The next step is set each factor equal to that 0. And now at this point, you solve both of these just like the homework problems we've been doing so far. Here I get sine of theta equals negative 1/2. Over here, I get sine of theta equals positive 1/2. And again, just today, I'm going to keep doing this a couple more times. We go to your table. We want all places that sine of theta equals 1/2. So it looks like sorry, negative 1/2 looks like here and here. Then we need all the places sine is positive 1/2. Looks like it's here and where'd it go? Right up here. So my solutions are, I've got a theta for the negative 1/2. It's equal to 7 pi over 6 and 11 pi over 6. And then over on this one, my answers are pi over 6 and 5 pi over 6. So those four answers together, pi over 6, 5 pi over 6, 7 pi over 6, 11 pi over 6, those are my four solutions. You don't have to do any extra steps. You don't have to check anymore. When you do that power, you'll get two separate factors. You'll get two separate equations, and each equation will give two solutions. Now, sometimes you repeat. Sometimes one of them only has one. There's a number of scenarios, but this is the general way right here. So you see what they were doing? Pretty much the same thing. Factor, set them up both equal to 0. Go look in our table and see, or you now have them memorized, and there's my four answers. There's my solution set. Okay, so next one, we have this 3 cosine square equals sine square. This one's a little bit more unique, but watch what they did here, okay? So remember a while ago, I talked about that Pythagorean identity, where cosine square plus sine square equals 1. We can use that. When we have a cosine and a sine, that's kind of like having two different variables. This is like if I gave you the equation 3x squared equals y squared. It's kind of hard to solve because there's two different letters in only one equation. Same thing here, but because you have the identity, you can replace one of these. So what they do is, and let me go back and show you how they're getting this here. Okay, so remember that identity. Sine squared plus cosine squared equals 0. Equals 1. I'm sorry, did I say 0? I meant to say 1. So that's our normal Pythagorean identity. So what they're doing is they're going to get this sign and they're going to replace it. So how do they replace it? It's like simultaneous equations. Let's move the cosine over so it becomes a minus cosine square. This right here is what goes and replaces the sine square. You see it right down there? So now they solve it, move the cosine over, move the 1 over, and you get 4 cosine square minus 1. Factor it. 2 cosine theta plus 1, 2 cosine theta plus 1. And, I'm sorry, one's a minus. Oh, yeah, I'm sorry, that was a minus 1. It's just like the last time we had that difference of 2 squares. This time, though, the difference is they're cosines. And look at your table. You don't know where it is. We're looking for all places that cosine is a half or negative 1/2. So we have pi over 3, we have 2 pi over 3, we have 4 pi over 3, we have 5 pi over 3. Those are my four solutions here. So there they are, and there's our solution sets. Okay. Okay, so on this next one, I'm sorry, same problem, different problem. Okay, I'm sorry. Sine squared plus cosine squared equals 3. Now, this is a unique one here because if you use that same Pythagorean identity, remember how they solved for sine squared and got the 1 minus cosine squared, and you replace it, what happens is something that it looks like it's a mistake. Okay. It looks like the first problem was supposed to be just cosine. From what I'm seeing here. Yeah, so make a note of that if you download this PowerPoint slide. It's supposed to be just a regular cosine, so that was the mistake. So we go the same way. We have our equation right here, and this is sine squared equals 1 minus cosine squared. Now notice what happens is when you have a regular sine or a cosine, you can't substitute that away. But when you have a square sine or a square cosine, you can sub that away. So we're going to replace sine with this 1 minus cosine square. just like before. So the whole sine squared becomes this. And then what happens is we get a cosine square sorry, the step that's not here was, I'll show you. Okay, so from this line right here, we have a 1 minus cosine square theta plus cosine theta equals 3. Now, the idea here is that whenever you have a square or any power more than 1, you're supposed to get everything on one side of the equation. So pretend it was this. If that was a 1 minus x squared plus x, you would get everything on one side of the equation, set it equal to 0. And then normally, people don't like to have that first term negative, so we'll get rid of that. That's the step that you don't see here. We're going to go in ascending order, a descending order. The highest power, the next highest power, and then the 1 minus 3 gives us a minus 2. So that's what we have here. And then the next step that they didn't show is, because it's an equation, I can just divide everybody by -1, and now I'm left with a cosine square minus cosine theta plus 2 equals 0. So that's how they arrived at this step right here. All right? So now, we look at the next piece here. All right, so you have it in descending order. Now they have, I don't know if I love this, but we'll get there in a second. But let me just kind of work with the problem and show you. First off, what you're trying to do is you're trying to factor. So like I was saying earlier, we move this PowerPoint down a little bit. If we divided everybody by -1, we would have this equation right here for the left. I know this is not our real equation, but it's a parallel. You see how they're similar? And I recommend this if you get stuck on the equation on the right and you're saying, well, I don't know how to get this, pretend it's that. And hopefully that'll ring a bell and say, oh yeah, I need a factor. And you're going to find, I'm going to come close. This gives me an x squared. It gives me the negative x, but unfortunately 1 times -2 gives me a -2. So I'm almost there. If I try this and I try this, this gives me the x squared, gives me the +2, but it gives me a -3x in the middle. And you can try it a few times, you're going to find out nothing seems to be working here. Okay? What the book wanted to do is they wanted to say, well, if you cannot factor it, you guys remember the rule, if you can't factor it, there's the good old quadratic formula. I know you remember your quadratic formula. So when I do this, here's how I'm looking at it. I'm not solving for x, so no x. Instead, I'm solving for cosine of theta. Because remember how it's the x was a squared, a 1, and a nothing. It's a cosine that's a power of 2, and then a cosine after that. So that's what we're solving for with the quadratic formula here. Okay? So when I plug in my numbers, it's cosine theta, and we're just looking at the coefficients, whatever's in front of there. So it's -1, plus or minus the square root of -1 squared minus 4 times 1 times 2, all over 2 times 1. And you see what happens here, if you're looking ahead, and they kind of pointed that out in the slides already, I get a 1 minus 8 inside that root. That means I'm going to get a -7. We're not going to get any real number solution. No real number solution. Because I'm only going to get imaginary numbers. So this happens sometimes. And this is one of these cases where we tried to solve it, but there really is simply no angle that'll work. So there's no solution. Empty set is our answer. Okay, it happens once in a while. Just wanted you to be ready for it because you'll see that on the homework there. All right. Now, in this particular one, we have 5 sine x plus x equals 3. Okay, and it's a unique one because you have a variable that's a regular variable, and then you also have one that's inside the trig there. So we've got a lot going on here. All right, they tell you trig equation cannot be solved by previous methods. A graphing utility, though, can be used. So I tried not to give too many of these, but when you get these ones that say a graphing utility, I definitely don't put them on the quiz. If you do, excuse me, if you do come across one on the homework, don't make a big deal of it, as in, don't stress about it too much. If it comes up, go to, and you don't have a graphing calculator, go to Desmos. You can always do this one, the one I like to use. And the process is literally just type this in. 5 sine x plus x equals 3. And they give you the graph right here. Now, it looks like it's just 4 lines here. Zoom out a little bit and you'll see, maybe, yeah, this one's going to be bouncing up and down a lot here. But what we're trying to look for, remember, is where is this, what's the solution for x, okay, on this? So, okay. It's not a bouncing up and down graph. All it is basically showing you the 3 solutions. So I kind of wanted to give you a little bit more to it, but you could do it this way. I'll give you another option here. Basically, I'll tell you right now, these are the 3 answers. These lines right here are the actual answers. Now, it's hard to tell, but I can see that's a 1. That looks like it's a 3 point something, probably a pi. This is probably something a little bit less, but we're estimating, so we don't want to do that. We don't want to do that. So I'll make it a little bit different. Let's say we get y equals 5 sine x plus x, and you see it's a very interesting sort of sine graph that keeps going up and down like a staircase. And let's see what happens when we have y equals 3. That is a horizontal line right here. What we're looking for is look at where they collide. That's going to tell you the x values where everything happens. So you see our first solution is at point when you hover your mouse right over it. I'll zoom in a little bit. When you hover your mouse on the solution, you get, it pops up the point, 0.519. Over here, 3.177. And here, 5.71. Those are our 3 solutions. And that's exactly what they did over here. So the solutions, and then you look at it and you see it gives you those points right there. So that's all it is. If that's the case and you have a graphing calculator, that's all you need to do is just pull up that and just manipulate the graph a little bit to see it. But like I said, I'm not going to give you this on the quiz, the graphing required one. But I may give 1 or 2 of these on homework. I usually don't put too many of them in there just because I know everyone has different graphing calculators, if you even have one, and you do not need to have one for my class here. Okay, so finish out this. Let's talk about the the assignment here. Our last bit, we did the 7.2 stuff the other day. Now we're going to do 7.3. So looking in the homework here, see, there's a 7.2. Let me jump to the 7.3 stuff just to give you some coverage here. And work out a few of these problems just so you understand how they're going to work, and what kind of format, what kind of answers you have to give here. Now you see this first one here, this number 3. In case you forgot, I mentioned this a few times. This is just a non-trig equation. They want you to come up with the answer. So how do I do that? I'm going to factor this and this. Now I'm trying to think, what multiplies to be -2? What do I put where? And I believe if I put this here and this here, I'm going to get a 1x and a -6x. That gives me my -5 right in the middle. So my solutions will be 3x plus 1 equals 0. X minus 2 equals 0. So x is -1/3, x is 2. Those are my 2 solutions. Now again, why I like to do this homework here as part of our video lectures is just want to make sure you plug in the answers. Simplify the answer, meaning reduce any fractions. Type an exact answer using radicals or fractions. Exact means don't go to a calculator. Don't give me a 0.3. make sure you type these in exact. So they want a negative 1/3 and then give a comma and then a 2. It's not a coordinate, it's a set. So you could have said 2 comma negative 1/3 or negative 1/3 comma 2, and there's our solution there. Okay, that's all they wanted on this one. So let's look at number 47. All right, on this one, state whether the following statement is true or false. All right. So we have sine of theta equals a half. The solutions to that one are these two. Okay, so when they give you a solution, remember, here's my equation right here. You're going to plug in this, and then you're going to do the same thing down here, same equation, and you're going to plug in the other one. And you want to see if they're true. So when I plug in pi over 6, I remember, oh yeah, sine of pi over 6 is a half. Do we need to see the table? Hopefully, like I said, as you do more and more of these problems, you get to know them. Sine of pi over 6, 1/2. We knew that, right? And then, of course, sine of 5 pi over 6. Is that also a half? Looks like it. So therefore, that's true. That's true. It's only going to be true, by the way, if they give you a true-false statement. This is only going to work if both of them are true. Okay? I'm not sure where this negative pi over 2 comes in, but we didn't need that. We just want to state this last one, D, and we have our answer. Okay, so read the statements, read the choices, make sure that everything matches, and then make your solution. Especially when you're doing the quiz. Homework, you can get away with it because I'll let you do it again or even a third or fourth time. When the quiz, it's one or done. So make sure you read it carefully and you understand what they're asking here. All right, so on this one, we have 2 sine theta plus 5 equals 4. So remember the process. Let's get this trig function term by itself, then divide by any number in front of it. Now I have sine equals negative 1/2. Okay. Think of your table here. Where is sine negative 1/2? I know we're going to be in the third and the fourth quadrant. Right here, we have our our 7 pi over 6 and our 11 pi over 6. There's my answers. 7 pi over 6. And you notice, by the way, when I was doing that, when I hit the comma, it's putting the comma by the 6. Just got to hit the tab button, and now you can make a new equation. 11 pi over 6. And there's our solution. All right, let's look at number 55. Okay, so we have an equation right here. Solve the equation 4 cosine square theta equals 1. Just like the examples I was doing here, you want to make sure you think of this as if that was an x square, 4x squared minus 1, what would you do? Anytime you have a power of 2 or more, your goal is to get everything on one side of the equation. So here's what I have. Let's move that 1 over so it's a minus 1. And now I'm going to factor. So I have the difference of 2 squares here. We have 2 cosine theta plus 1, 2 cosine theta minus 1. And set both of these equal to 0. So that becomes 2 cosine theta equals minus 1. Cosine theta equals negative 1/2. Over here, 2 cosine theta equals positive 1. So cosine theta equals 1/2. And look at your table. Figure out where these are. For the negative 1/2, think of your quadrants, think of the pieces. And like I said, as you get more and more comfortable with these, you're going to start to know these instead of looking at your table. See why I keep saying it's like knowing your times tables. You can't think of them every time. You can't look them up every time. You have to be able to know these. So starting with the 1/2, I know that's going to be at pi over 3. I know it's also going to be in the fourth quadrant, 5 pi over 3, and negative 1/2, second and third quadrant. We're going to get a 2 pi over 3 and a 4 pi over 3. And try it like I'm doing. Okay, did I get it right? Let's look. Cosine of 1/2, pi over 3. Cosine of negative 1/2, 2 pi over 3. Another negative 1/2, 4 pi over 3. And a 1/2, 5 pi over 3. So kind of get to that point where start trying to do them in your head. Try to see if you remember them. And then go ahead and feel free to check your table to make sure you got it right. Then go from there. Now notice, I don't have to put these in numerical order, like pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. I can put any order I want, quite honestly. You see, I'm just sort of picking a random order here. Main thing, as long as you get it right. So there's my 4 answers. A set does not have to be in order. I hope they didn't mark me wrong. They didn't, so we're good. And there's our solution on number 55. Okay, let's see 59 here. All right, now we get that 2 theta. So this is going to take a little bit more writing. So show you how we go about this. This is going to take the whole screen. They want to know what's the solution here to this equation, cosine of 2 theta. Notice all that's in the parentheses. Cosine of 2 theta, excuse me, minus a half equals 1. Okay. So now my answers have to be also, I'll put a little note over here. It's got to be greater than or equal to, sorry, writing a little bit too high on the screen there. All right, all my solutions, greater than or equal to 0 or less than 2 pi. So forget the fact that it's got all this in here. We just have to think cosine of what equals 1. Now remember, it's only going to happen one time. Oh, where is it? Sorry, right here at 0. Here it's negative 1, and here it's too big. Oops, sorry. It's too big, but what I want to start with is you set that entire inside and say, well, that's going to be true when the angle is 0. If that whole inside is 0, then the cosine of 0 is 1, so we're set. So solve this one. Move the pi over 2 over. We get the pi over 2 here. Divide both by 2, and we get theta equals pi over 4. So there's our solution, but remember, there could be more, especially because of the 2 theta. So remember the process, how we do this. You take the first equation when the trig function disappeared. And on that one, I'm going to add the 2 pi to the right side. So I keep the left exactly is, but over here, let's add a 2 pi to that and see what we get. So I get a 2 theta equals 2 pi plus pi over 2. So 2 theta equals, looks like 5 pi over 4. Now some of you may say, that's too big, that's bigger than 2 pi. You're right, but that's what we only look at that when we get to the final theta. And you notice now when I got this theta, I got 5 pi over 8. That's less than 2 pi. That one's still good. Okay, now I'm not done yet. I'm going to take the same thing. We're going to do it again. And this time we're going to add another 2 pi to it. You're going to keep going until you go out of bounds. So now I'm going to add 4 pi to my answer and do the same thing. Solve for theta. We get 4 pi plus pi over 2. 2 theta equals, it looks like it's a 9 pi over 2. Common denominator of 2, we get 8 pi over 2. 8 pi over 2 plus pi over 2 is 9 pi over 2. Divide both sides by 2, and we get 9 pi over 4. Okay? Is that too big? That's the question we have to ask ourselves. Okay? 9 pi over 4. Go in your calculator if you're not sure. Remember, the limitation is 2 pi. So, wrong one. Nothing bigger than 2 pi. Well, 9 over 4, that's 2.25 pi. That's too big. So we know this one is not a solution. So the only solutions that looks like I have are these two right here. I've added 2 pi, it worked. I added 4 pi, it did not work. And I have my original. The other option is I can subtract 2 pi. So 2 theta minus pi over 2 equals 0 minus 2 pi. But you'll see pretty quick in this one, we get a negative 2 pi. Let's fix that, sorry. That's a 2 theta on the left side. 2 theta equals negative 2 pi plus pi over 2. This is going to be a negative answer, so that one's out as well. Well, only answers I've got are pi over 4 and 5 pi over 8. So let's give it a try and see how we do. Pi over 4, 5 pi over 8, and we're missing something here. Okay, now this is important because it's going to help you figure some of this out. They give you kind of a little hint here. Now, they went with the general formula. I was sort of playing around without that, but let's see if we can go. Maybe the general formula will help. Maybe it won't. See what we have here. So, back over here. Okay, so mistake. See if you can spot it. If you didn't already. I was kind of thinking ahead, and I wrote what I was thinking instead of the right answer right here. So you look at this one. Okay, and let me just rewrite this so you can see what this is. This is 2 pi plus pi over 2. Common denominator, it should be a 4 pi over 2 plus pi over 2. It should be 5 pi over 2, not 4. Then when I divide both sides by 2, it becomes a 4. That's what I was supposed to have right there. So my answer should have been pi over 4 and 5 pi over 4. And a way to know that I should have caught, if you're getting different denominators, something may be funny here. One of them may be wrong. And now we have our answer. So that's all it was. Okay? So process is the same. You just, some of these complicated ones, you have a couple extra steps on the back end, but nothing too bad. Okay, so let's move on here. Make sure I get all of these here. Trying to clean up the screen. Let's look at number 63. Okay, so I want to use a calculator to get the 0.97. Now, I'm going to show you a picture, because the picture is what's very important here. So remember, we're talking about the sine function. And you guys know, well, hopefully you know, sine is positive here and here, it's negative here and here. When you plug into a calculator, it's going to give you a solution there. So the focus on this one is, well, we want to know where sine is 0.97. That's a positive. There's going to be one right here, some theta, but there's also going to be one over here that's also going to be a solution. The problem is your calculator is just going to give you the one there in the first quadrant. So get our calculator and I'll show you what I'm talking about here. Because remember, calculators are programmed to only give you the restricted area, the restricted regions. That means give solutions only in the first or the fourth quadrant. So if I have the 0.97 and I do the inverse sine, make sure you're in radians, inverse sine, we get this 1.325. Now they say round this to two decimal places. So one of my solutions is 1.33. Okay, rounded to two decimal places. That's this one right here. Okay, however, I want to know what this other theta is. Okay, so I'll show you how we go about finding this. Let me get rid of the pluses, minuses. This is going to work for cosine and sine. Tangent, we kind of talked about that. That's going to be a little different story, but we'll talk about that again. So here's our first one. I want to know what that angle is right there. That's my second solution. But what you're going to know is, just think of the ones you already have done, sine and cosine are symmetrical, up and down, right and left. So the other one here, remember these are my two positive quadrants. The other one right here, I don't know what the solution is, but I know it's going to be a mirror image and it's going to have a 1.33 right there. Okay, but the problem is I want that amount. Well, it's not a problem because I know this whole thing is pi. What I'm going to do is I'm going to take pi and I'm going to subtract the 1.33, and that's going to give me my other part. So the way to do this in the calculator, put a minus right there, add pi to it, and voila, you're left with 1.82, and that's your other piece, the one that you don't get from a calculator because it's not looking at all solutions between 0 and 2 pi. It's just going to give you the ones that are in the restricted quadrants. So the 1.33, most people will get. If I gave this on a paper test, almost everybody gets this. They always forget how to do the second part. So this is what you would do there for number 63. All right, let's look at number 67. All right, again, we're going to use a calculator, but you can't just plug it right in the calculator. There's going to be a couple steps to start here. So we have 6 cosine of theta minus 5 equals 0. 6 cosine theta equals 5. Cosine theta equals 5/6. And now that's what we're going to put in our calculator. But before we do that, I'm going to keep reminding you. Cosine, it's positive, so we're going to get an answer here and here. We need to get two answers, one for each quadrant. So cosine, sine, tangent, all of them, they're always positive in two quadrants. They're always negative in two quadrants. If you have a negative and you're looking for the solutions, you need to have one here and you need to have one here. You need to give them both. But the calculator is only going to give you that first one. It's not going to give you the second one. So just like the last problem, we have to do a little maneuvering. So we did it with sine. I'll show you how to do it with cosine. Type in the 5/6. We get this. Now, by the way, some of your calculators, well, I don't even have it. I'm sorry. Some of yours has a fraction button. Looks like x over y, y over x, b over c, a over c, a over b, something like that. You could do that. I don't happen to have that, sorry. So just do the division. As long as you don't round it, your calculator is going to treat this like a forever decimal. It is the pure fraction. So we're in radians. Let's do the second inverse cosine, and we get this 0.59. So remember where this is. Here is 0.59. That's my solution, the one that we knew, the one the calculator gave. But we need to know what this big one is, all the way around. But there's going to be the same symmetry. If this is 0.59, here is going to be negative 0.59. So to get the other answer is, well, I want to know what the rest of it is. A full circle is 2 pi. We want to get rid of that 0.59. So sine, remember we were subtracting this from pi. For cosine, I'm just going to subtract that from 2 pi. So I'm going to add a pi, add another pi, and now we have this 5.69, round that up to 5.70, That's my second solution. Okay, so hopefully we'll have the 0.59 and the 5.7, and there's our solution. And that's it for number 67. So just like the last one, number 63, but with cosine, draw the picture. Remember, you're going to get two solutions, one in each of the quadrants that are either both positive or both negative. It's got to be the common ones. Okay, let's look at 71, sorry. We have sine square. Sine square theta minus cosine square theta equals cosine theta plus 1. Now, this is kind of a precursor to what you're going to get in Calc 2 a lot, but we'll talk about it now. This is my connection between sine and cosine. Cosine square plus sine square equals 1. We can replace either one of them. We can solve for cosine square and get 1 minus sine square. We can solve for sine square and get 1 minus cosine square. The question is which one? Because we have a couple of squares here. This is the one that tells you what to do. I can replace sine. Sine square. I can replace cosine square. I cannot replace cosine. Therefore, that thing's locked in there, which tells you leave the other cosine square, but instead, we're going to get rid of the sine square. And what that's doing is it's going to leave us with all the same variable, all cosines. So solve for the sine square, which is again something you're going to get to know pretty quick. Sine square is 1 minus cosine square, and that's what I'm putting right there. So now I'm going to clean things up. I get negative 2 cosine square. Move the cosine over, that's a negative cosine. Move the other one over, and they actually cancel, so we get just a 0. I can divide everybody by negative 1 if I want, just to give me that first term being positive. Makes it easier to factor is how I look at it. As long as you do it, and it's an equation, you do it to every term, you're going to be fine. So now, how do we do this? Remember the rule. As soon as you get it equal to 0, your job is to factor. Well, the first step of factoring is there a greatest common factor? Yes, there is. Cosine theta. Pull out the cosine theta. We're left with a 2 cosine plus 1. So now you set each factor equal to 0. And it looks like we get a cosine theta equals negative 1/2 over here. So these are my preliminary answers. We still have to go think of our table and think of where this is true. So let me move this up here to the top. We have cosine theta equals 0, or cosine theta equals negative 1/2. Now be aware, you don't want to accidentally pick where cosine is positive 1/2. You got to make sure you get the right ones. So from right here, I know theta is pi over 2 and 3 pi over 2. That's it. That's the two places that cosine is 0. You want to check? Look at your table. Look at mine. Cosine is 0 at pi over 2. Cosine is 0 at 3 pi over 2. So we have, we have those two solutions for that equation. Now, there could be potentially 2 from this one. You got to think, where is cosine negative 1/2? Well, cosine is negative in the second and third quadrants, so focus your attention there. And hopefully you see there's a 2 pi over 3 and a 4 pi over 3. Those are my 4 solutions that I'm going to plug in to this problem. Okay, let's see if I can read this without. Okay, now they don't have to match. They come from different places. So we get a pi over 2. We get a 3 pi over 2. We get a 2 pi over 3 and a 4 pi over 3. And there's our 4 solutions. Okay, let's do a couple more of these. Let's do number 75. See how that one is. Okay, same kind of question as the last ones. They just, of course, they're going to get a little bit progressively more difficult. And I won't say the difficulty is huge, it's just increasing slightly as we go on with these problems. Okay, now this one, what's nice is they're all sines already. I see a sine square, so that's going to tell me right now I'm probably going to get double the normal two solutions, so I should get four solutions. Sometimes there might be repeats, sometimes some aren't going to work, so we'll just see how this goes. The similar equation I want you to think of is 3x squared plus 10x plus 7 equals 0. Think of how that factors, okay? Because remember, when you get a quadratic, which is a square, sine square, your job is to factor everything once you get everything on one side equal to 0. So I get the 3 sine and the sine. And I got to think of what goes where. It looks like I'm going to put the 7 there and the 1 there, and then check your math, check your factoring. I FOIL this out. I get a 3 sine square. I get a 7. And then I get a 3 sine plus a 7 sine. So I do, in fact, get that 10 sine in the middle. So now we set every factor equal to 0. And then we solve. This gives me sine of theta equals negative 7/3. This one is just sine of theta equals negative 1. And I think, well, I know this one. This one's pretty easy. It's going to be 3 pi over 2. I got that one. But this one's a little bit weird because I don't have that in my table. You guys know the table. There's no negative 7/3. There's no positive 7/3. You will know this if you remember a couple facts. When I divide 7 by 3, I get 2 1/3 or I get 2.33. Remember, sine and cosine, the maximum they can be is 1. They always go from 0 to 1 or negative 1 to positive 1. This is too big. We will never get a solution for that one. So that gets thrown out. My only answer to this problem is going to be 3 pi over 2. And that's it for number 75. Looked worse than it was, but once you get it set up, now you treat this as two independent problems and you solve both of those. Okay, so for this last one, number 79, solve it with the graphing utility. Like I said, I'm going to put a couple of these on the homework once in a while. Don't worry. Try them. Don't stress about them, though. So we did one just like this here. We have the equation x minus 3 cosine equals 0. So break that up into two pieces of what they did. Okay, and like I said, if you type this in, you'll see what happens. X minus 3 cosine x equals 0. All it does is it just gives you the solution lines. Okay, it doesn't tell you a lot. So the easier way is let y equal the first part. Y equals x minus 3 cosine x. Oops. There's that kind of staircase one like we did earlier. And the other one is just simply what's on the other side of the equation, y equals 0. And now, where do they intersect? That's the question. I see it looks like it's going to be at a couple spots, and they gray out the dots. So I have a negative 2.938, and they say go to the nearest two decimal places. So let me just kind of write this down here. We have x equals negative. Okay, get your mouse and hover right over it. Negative 2.938. They want the nearest two decimal places, so we'll call it negative 2.94. The one right next to it, there's another one, negative 2.66. And I see another one, not there, but right there, 1.17. So I'm just writing them down so that I can type them in a little bit faster here. Negative 2.94, negative 2.66, 1.17, and that's it for the homework there. So from what you see here, you should be good to go on doing all these problems in the homework and even looking at the quiz. Um, let me just give you a quick preview of what the quiz is. Back to our assignments here. Quiz number 4. Now remember, this one's due on Monday, so you still have all weekend to get this done. Your focus should be homework 3 and quiz 3 on Friday night. That's due very soon. But the quiz, number 4, again, I'm giving you guys 2 chances at this one, so that's a good thing. All right, 55 minutes. So make sure, as I mentioned, a little reminder, make sure you have that 55 minutes to spare. If you have to go somewhere in 30 minutes, don't start a quiz knowing that you have to leave in the middle of it. Make sure you have the allotted time, because once you start it, that clock counts. So I just want to run through a couple problems, let you see how they work. Is the graph 1-to-1? Okay, basically, is it going back and forth here? Choose your correct choice. You just have to look at, is this interval and this interval going to be the same one? So you had a couple like these in the homework. That shouldn't be too obscure. Okay, write the trig expression as an algebraic expression in U. This is that one where it was one of the later problems we did in 7.2 the other day. You set up your triangle, okay? This is going to be your theta. That parenthesis, remember, anytime you have a trig function, that's going to be your theta. So secant of theta equals U. Same as secant of theta equals U over 1, which is the same as cosine of theta equals 1 over U. Remember with the reciprocals? So now, let's get rid of that. I'm going to draw a triangle. I don't know where to make this go because it isn't clear what our theta is, but let's just draw a standard triangle. And since cosine is 1 over U, that means that's 1, that's U. And for this y value, I'm going to do the Pythagorean theorem. And you see I get y equals plus or minus the square root of u squared minus 1. That's my y value. Okay? And then our final part is they want to know what's the sine of the given theta. So looking at my triangle right here, I know, since that's the y value right here, it's y over r, so it's going to be square root of u squared minus 1 all over u. And again, I have a plus or minus. Now, they didn't specify if it has to be positive or negative. They didn't really tell us anymore. If you want to get a very technical, very official, you should put the plus or minus, but I'm pretty sure we can just get away with saying the positive root. X squared minus 1 all over u. Of course, I can't check my answers, but we'll check it at the end there. Okay, so that's all you would have to do. Here, this is a calculator problem. Remember, you can flip this over and make it a tangent, but go with what we did the other day where let's write this as a cosine over sine, and let's do a substitution to get that one. Make the triangle is what they were doing. Make your triangle, solve for the x, y, and the r, and then go find the inverse cosine of that one. That'll guarantee that you're in the right quadrant. Here, you have a trig function, x-intercepts, graph it on this interval, solve it, draw part of it, something you've done before. This may take a couple more steps, so keep this in mind. This might be one to specifically study for quiz number 4 before you jump on there. This is one like we did today. You're solving the equation. Now remember, if you have 2 different trig functions, you have to get rid of one of them. You got to make them all the same trig. Anything with a power 1, you cannot move it. So that's locked. You can replace the cosine square with a 1 minus sine square. Then everything is a sine. So you get everything on one side, factor, set it equal to 0, set each factor equal to 0, and then solve and get your solutions. Remember again, you normally get 2. Not always, because we saw some exceptions where sometimes answers got thrown out. But typically you get 2 solutions for every problem. If there's a square, then you're doubling it, you're probably going to get 4. So if you only get 2 answers here and you never saw 2 others, you've probably missed something. Okay, if you saw 4 solutions and you threw out a few, then that's okay. Then you know you're down. But if you just get 1 or 2 answers and you have nothing else, you probably are missing something when it's a square equation. Okay, number 6, again, like number 4 earlier, make the triangle. Let this bracket be theta. Make that, tangent of theta equals root 3 over 1. Build your triangle. Use the Pythagorean theorem to get the third side, and then go find the sine of that triangle, and you'll get your solution. Number 7. This is one like we did today, almost exactly like one of the ones we did today. Remember the trick. When you have a 2 theta, you're probably going to get more answers. That's the one where you have to, as soon as you get rid of the trig function, you add 2 pi to each solution, so you produce more answers. Review that one. You'll get familiar when you go through the homework on that one. This one's an interesting one. A little bit of a word problem. They got our trig functions right here. What are they asking for? The angle of incidence, and they talk about it. They want you to find that theta right there. So what this is they just want you to take the stuff you see right here and try to come up with somehow finding what it is. Okay, where it is. You have a theta, you have this right here, and make sure we see where that came from there. Yeah, work with that. I may even change my mind on this one as I see it, but see what you get. I'll give you a preview of this one. Not everyone will get this problem. A couple of you might, but it's just a matter of rewriting some stuff and trying to figure out what you have here. And they define it all up here. Like I said, look at it. I may change my mind, but just kind of be ready for something similar to this one, where they're just making you apply the concepts. This one right here, you have a sine function, you have a cosine function, you have a tangent function. They want you to find the exact value of the composite. Now, what they're saying is you want to take the inverse sine, and this is all it is. It looks a lot worse. Replace the h with tangent. So instead of h, we're going to write tangent. Instead of f, apologies, we have sine. You're going to put an inverse sine right there of negative 21 over 29. And after that little rewrite, now the problem looks like the one we just did. There's your theta. Go build your triangle. Sine of theta is negative 21 over 29. Use the Pythagorean theorem to get this. And actually, that should have been down here. Negative 21 over 29. There's your theta. Go get the x of the Pythagorean theorem. And then last, go get the tangent of that. So you're going to put this over whatever you find, and that's your answer. So it looks really complicated, but when you see that, just replace f with sine, replace g if there was one with cosine, and replace h with tangent. There was just nothing for g right there. So looks worse than it really is. And the last one, just like one we did today. Set it equal to 0. In this case, you can't factor it, so I would go the other route, actually, and say, let's let the cotangent of theta equal negative 1, and then remember, cotangent is cosine over sine. So you ask yourself, in my table, where is it that when I divide cosine and sine, I'm going to get a negative 1? Well, only time you divide cosine and sine and you get a 1 is when they're the same, which is either here, that gives you a positive 1, here that gives you a negative 1, here that gives you a negative 1. Oh, sorry, that gives you a positive 1. Here, this one gives you a negative 1. Another way you can actually solve this, if some of you are wondering, and we're right here, I can multiply both sides by sine and get this. And now it's basically saying, go look in your table and see where sine and cosine are exact opposites. And that would be here and here, and there's your answers. The pi over 4, sorry, 3 pi over 4 and 7 pi over 4. Okay, so that's it for the quiz. work on the homework, work on the quiz. For Friday's class, my ideal plan is that you're playing this video while I'm in a meeting, I'm sorry, and I'm going to try to chat with you and answer questions during that. I can't guarantee how well that's going to be if I have to speak or something's going on, but what I would say is, bear with me on this one Friday and let's watch the video. If you have questions, just email me if I'm not answering quickly in the chat. Shoot me an email and I'll work with you on Friday and Saturday and Sunday, whatever the case, and I'll try to work with you one-on-one if you need. And if anyone needs to meet with me over the weekend, I can open a quick video chat here and we can go through a couple of these problems. So talk to me, let me know. Have a good weekend. Don't forget, quiz 3 on Friday, quiz 4 on Monday night. All right, have a good one.